So welcome back everyone, and we are carrying on. We're looking at question number 7 on page 86. As always, if you haven't tried this question yourself yet, have a go at it before watching how we do it. Right, I'm going to try and answer this question sort of in the space available up at the top here. The first part of the question just asks us to write down the coordinates of A. Now that's fairly obvious because A is in standard form, so the center of A is -2, +6. Right, remember that the center coordinates are the things that make these two brackets 0. So -2, 6. All right, so that's fairly straightforward. The next one says, determine the radius of circle A. All right, now we don't know the radius, but we do know that point B lies on the center. All right, so on the edge of the circle. So all we need to find, our radius, is just going to be the length of AB. Okay, so it's going to be AB, and we're just going to use our distance formula. All right, the change in the x values from -3 to -2 is just 1. So we're just going to square 1. And the change in the y values is actually also 1 from 5 to 6. So we're going to square 1. And so the radius is the square root of 2. All right. Okay, so that's part B. Part C says determine the equation of this tangent. Okay, and this is a fairly standard question because to find the equation of a tangent, we're going to find the equation of this radius. All right, and that's fairly obvious because we've already spoken about the y changing by 1, the x changing by 1. So our answer to question C, the gradient of the radius, the gradient of AB, the radius, will just be 1 over 1. It's definitely going uphill. All right, and that means that the gradient of the tangent must be -1. We're going to turn that over and change the sign. All right, and then lastly, it needs to go through the point -3, 5. We're going to do this one with y minus a y value is the gradient x minus the x value. So it's x minus -3, so it's actually going to be x plus 3. Okay, and our final answer is going to be y equals -x. Now on this side we've got -3, and we're going to add 5, we're going to get +2. Okay, and that's looking kind of about right. I say about right because if that point is at a height of 5, then the y-intercept of this graph is looking about 2, is looking about right. Okay, remember we can, instead of this y minus y value formula, we can also use our y equals mx plus c formula. Right, so there's the answers to, this was the answer here to B, here's the answer to A, and then the next question says, if AB to BC is a third, determine the coordinates of C. So what that's saying, and we've just done some geometry, this is like P as to, AB as to BC as a third. This is like P as to 3P. Right, what that means in terms of ratio, that means that when we go from A to B, we've gone 1/4 of the way along the line AC. All right, so we need to, whatever that gap was 1 when we go from A to B, the x is changing by 1, it's decreasing by 1, it must decrease by another 3. So this point here will be -6, all right, and the y values drop by 1, it must drop by another 3, this value here will be 2. -6, 2. And again, that's making us feel comfortable because we said that was 2, and that seems to be at the same height. All right, all we're doing here is we're just thinking about ratios. Another way of thinking about it, if we want to go 1/4 of the way down this line, okay, then that's 1/4. This other piece must be 3/4. Okay, all right. So it's just about scaling up what's happened to x and what's happened to y. All right, so then write down the coordinates of f. So that's literally just write down. So find the center of this circle. Now, f is not in standard form, so we're going to need to put it into standard form, right? And we've done this so many times. So here's our answer. This was our answer to D. Our answer to E is just going to be to put this equation here, this green one, into standard form. Okay, so let's start off by just collecting everything that's got x's and y's in on one side. So it's actually going to be x squared minus 2x plus y squared minus 6y equals 1. Okay, now we're going to get x minus 1 all squared and y minus 3 all squared. And this is going to be 1. We've added in 1 squared, so we must add in 1 squared here, and negative 3 squared. So we've added in a total of 10 here, so we must add in 10 here. This is actually not that significant. What we now know, though, is that the center is positive 1, 3, and that's the coordinates of f. Okay, right. We're now on to question number 8. All right, and we're going to ask you to pause the video here. This is a little bit interesting, this question, and see if you can find the equation of this circle. All right, what is not specified but is hopefully obvious is that the x-axis is a tangent to the circle. Okay, and there's a bit of a hint there. All right, pause the video and have a go, and then let it run again and see how you went. Okay, so the secret to this one lies in realizing that this line here is a radius, and so it must be perpendicular. And because of that, the x value of this point must be 2. All right, I don't know what the y value is, but I'm just going to say y. All right, now, what we know is that we know that the distance between these 2 points, all right, which is actually just going to be, if we think about y is a negative value, right? So that distance would be negative y, all right? Another way of showing it is if we work out the two distances, okay? So we're going to work out the distance MA, which is a radius, and the distance MB, which is a radius. Those two things must be equal. Now, so what we're going to do, we're going to go 2 minus 2, 0 squared. We're going to go 0 minus y, we get negative y, but we're going to square it, so it's going to be y squared. We're going to get, here we're going to get 2 minus 4, which is negative 2, which when we square it becomes 2 squared, becomes 4, and y plus 6 squared. Okay, now we're going to square both sides. All right, so when we square both sides, here we get y squared, and on this side we get y plus 6 all squared, and we've still got the plus 4 as well. Okay, and all we're going to do now is solve this quadratic equation for y. All right, it actually ends up not being a quadratic equation because, so I apologize, we're going to go up here now. We're going to, on the left hand side, we're going to get y squared. On the right-hand side, we're going to get y squared plus 12y plus 36 plus 4 is plus 40. So the y squareds actually subtract, all right, and we get 12y plus 40 is 0, or 12y is negative 40 if we subtract 40 from both sides. Now we're going to divide both sides by 12. So we're actually going to get negative 40 over 12. All right, both those numbers divide by 4, which is negative 10 over 3. We did expect y to come out negative. Okay, now the last thing we've got to do is write down the equation of the circle. Okay, so I'm going to write it up at the top here because it's going to be x minus 2 all squared plus y plus 10 over 3 all squared. And then the radius, guys, the radius is going to be 10 over 3. So the answer to this is going to be 100 over 9 because that's the radius squared. So there's our circle. Then we are asked to find the equation of the tangent to this circle. Okay, and that's not too bad because we know what y is now. So we know the gradient of MB. Remember, we're going to take our y values and subtract them. So we're going to go minus 10 over 3 minus the other y value of minus 6 over our x values, which is 2 minus 4. Notice I'm expecting a negative answer because MB is the radius. It's a line going downhill. Okay, so there it is. Okay, and we can put all this into a calculator. Okay, we actually, when we do that, we actually get, let's see if we can do it without a calculator. Okay, this is going to be negative 10 over 3 plus 6. And on the bottom, we've got negative 2. Let's multiply the top and the bottom of this fraction by 3. And the reason being is that will get rid of the sort of triple-decker fraction that we've got. So if we multiply this whole top by 3, we get negative 10 plus 18. And if we multiply the bottom by 3, we get negative 6. So we've now got 8 over negative 6 or negative 4 over 3. Remember, we said we expected a negative answer. That's the gradient of the radius. So therefore, the gradient of the tangent will be perpendicular to that. So we're going to flick it over and change the sign. What we should have written on the previous one, which I realized we didn't, is why are we doing that? Radius perpendicular to tangent. And then the last thing we've got to do is use either y equals mx plus c or y minus y value. This time I'm going to use y equals mx plus c, and we're going to put the point 4, negative 6 in. All right, so y equals mx plus c. All right, and we're going to put the point in and the gradient in. So remember, it was 4, negative 6. Negative 6 being our y value, 4 being our x value. Okay, the gradient being 3/4. Now remember, 3/4 is 3/4. The 4 is 4 over 1, and we've got a plus c. This 3/4 times 4, the 4's divide out. All right, we don't cancel them, we divide them out, and we actually get 3. And if we subtract 3 from both sides, we get c equals minus 9. And then the last thing we're going to do is write down our final answer. Y equals 3/4 x minus 9. Okay, I like to, just when I'm finished with a question like this, I like to go and just look at the answer and see, does that sort of make sense? 3/4 of x minus 9. Yeah, I think that the y-intercept would be at about minus 9 if I had a tangent coming through here. Okay, like that. So we're saying that that point there would be minus 9. Okay, we hope it's making sense. It always makes sense. Okay, right, now let's look at this one. It asks us for the length of this tangent, and I hope you can remember how to do that. Let's pause the video, have a go, and then we'll record, let it play again and see. That's right. What we're going to do, we are going to work out the length of the radius. Okay, and we know that that's a 90-degree angle. Okay, then we are going to work out this distance. Okay, and then we can use Pythagoras. Okay, but we can't do any of that before we know the center and the radius of this circle. Let's put it into standard form. X minus 2 all squared plus y plus 4 all squared. We've got a 5 already on the right hand side. We're going to add in 4 and 16. So 5 plus 4 plus 16. Right, so in fact this actually comes to 25. Right, so we know the center and we know the radius. And in fact, what we know is we know that the radius squared is 25. Right, so I'm going to call that R. I'm going to call this AB, okay? And I'm going to call this OB. All right, now OB we can work out. Okay, and in fact, I'm not actually going to work out what OB is. I'm going to work out what OB squared is. All right. Now, so in other words, I'm not going to put the square root into the formula. This we know is the center of the circle. This is 2, -4. Okay, so OB squared, how far has my x changed? It's changed by 8. How far has my y changed? It's actually changed by 10. It's gone from -4 up to 6. That's 10. So OB squared is actually 164. OR squared, so OA squared, that's the radius squared, that line there, that is 25. And we know that AB squared plus AO squared, or OA squared, equals OB squared. All right, and that is Pythagoras. And the reason we can use Pythagoras is because we know that the radius is perpendicular to the tangent. Okay, so now AB squared, which is what I'm trying to find, is just going to be OB squared minus OA squared, or AO squared. So it's actually going to be 164 minus 25. And 164 minus 25 is 139. All right, and that's AB squared. So AB is just going to be the square root of 139. Okay, I don't have it asked for an accuracy. It didn't give an accuracy, but obviously we could work that out on a calculator and give it to whatever accuracy we needed. Okay, right, I think we're going to stop there and we'll pick it up again next time. Before the next lesson, try question 10, all right, and perhaps even question 11, and we look forward to going over it with you next time. Have a great day.